let's go on where we left off on Tuesday, and I'm going to put up one more question for us to do based on what we did on Tuesday. So if you remember, on Tuesday, we worked with quadrilaterals. We first had to identify the quadrilateral, and then using the quadrilateral's properties, we solved for the angle. So first we just started off with like x's and y's, but then we got to a point where we actually had to make an equation to solve for our x or y. So we're going to just do this question as a sort of a reminder of that. So let's see, everybody, what would you say? What kind of a quadrilateral is this and why? Remember, it's all about the reasons. You got to give your reasons. So put it in the chat. What kind of a quadrilateral is this and why do you say it is that quadrilateral? Pop it in the chat. I'm waiting for some more answers. Have some more answers, guys. Okay, so we've got different answers coming up. Some people are saying it's a rhombus. Some are saying it's a parallelogram because both pairs of opposite sides are parallel. That's the one reason I see people are giving. Then there's another one, two pairs of opposite sides are equal, opposite sides parallel. Rhombus, two pairs opposite angles. Okay, so we cannot, remember, we cannot make things up. We can only use what is given. And what is given is that the sides are parallel. They are definitely not equal. Remember, I went through that on Tuesday and I said, if sides were equal, there will be a little marker on the side, either a 1 or a 2 marker. That is not there. So we can't make it up. We're not Harry Potter that can make it appear out of nowhere. If it's not there, it's not there. Okay, we can only work with what is given. So what is given is that we have two pairs of opposite sides parallel. So if two pairs of opposite sides are parallel, then this would indeed be a parallelogram. And if you go to your screenshots that you took, or if you did your page with all of your properties, I don't have it here now, I would need to go hunt for it back in previous lessons, then you will have that two pairs of opposite sides parallel is the key characteristic of a parallelogram. So that's the only reason we can give here. It's a parallelogram because the opposite sides are parallel. Opposite sides are parallel. Okay. Okay, so there's, make sure that you understand very well that there's nothing here about equality. When we start off with the question, we just have parallel. There's nothing there about equal. Only once we come to the conclusion that that this is a parallelogram, can we add the other properties. So this one property is given, the opposite sides are parallel. And that means that this is a parallelogram. So now that we know it's a parallelogram, we can add the other properties of a parallelogram. Okay, so you guys must be sure of that thinking process of how that works. What is given, we identify the shape from what is given. And once we have the shape, we've identified the shape correctly, then we can add the other properties. So now we can say, yes, these opposite sides are equal. And we can also say the opposite angles are equal. And because the diagonals aren't drawn, we're not going to bother so much about the properties of the diagonals. But what we want to do is now solve 2x plus 2. We want to solve for x. So what is our equation that we are going to make? Put it in the chat with your reason. What equation are we going to make to solve for x? If there's an x, you have to use an equation to solve for it. Pop it in the chat if you know. Five x plus 2x plus 12 is 180, says Tuli, because of co-interior angles. I agree with you, Tuli. Let's see what other people are saying. Sakiwo, I think you just dropped your 0, but you also said that. So 5x plus 2x plus 12 is 180 degrees because of co-interior angles. Nice. Tabisa also got it. Everyone else? Just remember, even if your answer is in the chat already, pop it in anyway. That way you know that you are participating and giving it your best. Okay, so we have 7x plus 12 is 180. Okay, let's solve for x. Pop it in the chat when you know what x is after you've solved it in the equation. Lydia's super quick. Hannah's right up there. Anam. Let's see. Let's see if they're right. Okay, good stuff. So 7x is going to be 168, and then we divide by 7 on both sides, and that gives us 24. Okay. Right, last one. I'm going to leave you here for about 3 minutes to do this one on your own. Don't put anything in the chat. Just work on your own. Go through that same process we just went through. Identify the parallelogram and then use the properties of the parallelogram to solve for your variable. We can actually do this in 2 minutes, I think, because it's almost exactly the same as the previous one. Okay, so put in the chat what kind of shape this is and why you say it is that shape. Just listen to the question, everyone. I say just pop in the chat what kind of shape this is and why you say it is that shape. Don't put your answer for X in yet. Just tell me the shape and why. Amukulani says it's a palm, opposite sides are parallel, and I would agree with that. Opposite sides parallel. Okay, and now we're going to go 5x plus 3x plus 4 is 180. Co-interior angles. That gives me 7x plus 4 is 180. Wonderful, everyone. Be careful of equal. The sides are not equal. What is given is that they are parallel. Make sure you understand the difference between parallel and equal, because it is not given that the sides are equal. It is given that the sides are parallel. Thanks, Kat. 8x plus 4, and that's 176. And then we're going to divide by x by 8 and get 22. Okay, well done, everyone. Put a thumbs up in the chat if you got everything right. Everything as it is on the board. If you got that as is, put a thumbs up in the chat. Good stuff. Ms. Kat Sumaya is having trouble with her audio. If you could just assist her, please. Excellent. Okay, so Mammy's asking, what's the difference between a rhombus and a palm? Okay, so let me maybe get that. Where is my big shape organizer? Here it is. Here's my shape organizer. So a parallelogram has all these properties, both pairs, opposite sides, parallel, equal, etc. So a rhombus is actually a special parallelogram. The only difference between a parallelogram and a rhombus is the fact that the rhombus has all its sides, its adjacent sides are equal, so all the sides are equal, and the diagonals bisect at 90 degrees. So that's the difference. And if you didn't take a screenshot of this before, Mammy, then you must take one now, because this is what you need to learn and know for your properties of quadrilaterals. We get 176 because we are subtracting 4 on both sides. And so I was saying, okay, back to, let me actually copy this page because we might need it again. Okay, right, so that's that. Now, part of what you need to do is to prove that quadrilaterals are parallelograms, rectangles, squares, rhombi. Okay, so again, you need to really know your properties very well. But we're going to start off by just proving some parallelograms. Now, when you are proving something, it means that you have to take what is given and use other geometry to find the properties of that shape first. And because you find those properties using other geometry, you can then conclude that your quadrilateral is a parallelogram. So which properties are we going to look for a parallelogram? Exactly the ones that you've been learning and studying. Both pairs of opposite sides parallel, both pairs of opposite sides equal, both pairs of opposite angles are equal, the diagonals bisect, or one pair of opposite sides are equal and parallel. Okay, so it's important that you understand the whole idea of proving something. You have to prove it. You can't at any point just assume that it is a parallelogram. You have to prove everything first. You are like a detective solving a murder. You have to prove your case. Okay. So this is our first one. I'm going to go through it and you can just listen carefully and ask as many questions as you want in the chat. And also feel free to raise your hand if you have a question. So we said that to prove a parallelogram, we need to prove one of these properties. Okay, so we're not going to go crazy and try and prove all 5. We're just going to prove one property, because one is enough to then say that this shape is a parallelogram. Okay, so let's see. Again, remember that thing about what is given. We can only work with what is given and using other geometry. We cannot make stuff up or make stuff appear out of nowhere. Only what is given. Okay, so in this trapezium, okay, so that's our first sort of clue or our first bit of fact, that ABCD is a trapezium. So now already you can start thinking, okay, what do I know about a trapezium? Oh yes, the opposite, one pair of opposite sides of a trapezium are parallel. Okay, so now for geometry, it's really good to have some colors with you. So I'm going to highlight those things that are given in orange. So that's going to make it much easier as well when I write my proof and I need to write my reason, then I can just look for the orange bits. Okay, then we what's next is that AD is parallel to BC. Okay, we know that already, that's given. And then A is equal to D. A is equal to D. Okay, so here's the 70. That's shown already. Great. And I've got that on my sketch. And then EC is equal to DC. EC is equal to DC. Great. So what do I know about a triangle with two equal sides? It is an isosceles triangle, but that reason does not exist. We can only use angles opposite equal sides. So now I'm going to go on my fact-finding mission. And from what's given, I'm going to use my other geometry just to find some angles and sides and things. And I'm going to start here with the isosceles triangle and say that E2 is 70. E2 is 70 because of angles opposite equal sides. Then I'm going to go next to it, E1. I can figure out what E1 is. That's 110 angles on a straight line. Okay, so what other information do I have? I have those parallel lines. So what can I do with that information? Well, I can say that this is 70 because of co-interior angles. And then lastly, I can go to B and say this is 110 because of co-interior angles. Right, Mpendulo, you have a question. Go for it. You can unmute Mpendulo.
Why do we say 1 is 110?
Say again.
Why do we say 1 is equals to 110?
So E1 is equal to 110 because of angles on a straight line. Because if E2 is 70, angle E2 is 70, then angle E1 must be 110 because together they must make 180. Okay. Yes, Georgia Lynn.
Hi, ma'am. Is EC going to be common?
Where's E3?
EC, like line EC.
EC is a common side, yeah.
Common. Okay, thank you, ma'am.
Okay. And then Andy, you have your hand up. Andy, you can unmute. Andy, we're waiting for you.
Why is angle B equals 110?
Okay, because of co-interior angles. You see that AE is parallel to BC. So they are co-interior, and co-interior angles add up to 180.
Okay, thank you.
So Julie says, ma'am, would it be correct if I said E1 is equal to C1 because of alternate angles? Yes, perfect. Yes, E2, you're right. Okay, Tabiso, one more question. Yeah.
Why is E2 70?
Okay, do you see that EC is equal to CD?
Yes.
What do we know about angles opposite equal sides?
They have equal angles.
Yes, that's right. So that's why, because those sides are equal, the angles opposite those sides are also equal.
Okay, thanks.
Okay, right. So do we have enough information yet to say that this is a parallelogram? And if we say it is a parallelogram, which one of these 5 properties are we using? Are we proving? Which one of the 5 have we proved? Go through the list and check. We have not proved that both pairs of opposite sides are equal. Who says iPhone? iPhone, tell us your name so we can stop calling you iPhone. Andy says 3. Hannah says 3. Tombi Zodwa says 3. And Ivy's iPhone. Okay, Miss Kat, will you please rename iPhone to Layla?
There's 2 iPhones.
Oh dear.
A bit tricky.
Okay, so guys, let's go through the list. Have we proven that both pairs of opposite sides are parallel? No, we've got one pair of opposite sides and we have not proven that EC is parallel to AB. So that's no-go. Both pairs of opposite sides are equal. We have most certainly not proven anything with equal sides. Both pairs of opposite angles are equal. So we've got A is 70, C1 is 70, check one pair. B is 110, E1 is 110, check the second pair. So we have proven number 3. The diagonals we're not going to bother about because they're not drawn in, so we're not using them. And the other one we also haven't proven. Okay, now we have to write down everything with reasons because that's how you get your marks. Okay, so we're going to start by saying that DC, EC is equal to DC, and that is given. And then we're going to say that angle D is equal to angle E2 because of angles opposite equal sides. And because of that, E1 is equal to 110 angles on a straight line. Okay, so you basically have to put every step down. So we can say C1 is equal to 70, and you can use alternate angles or co-interior angles here. Co-interior or alternate. Remember to say that AE is parallel to BC. And then we're going to say angle A is equal to 70. Why do we say that? Because that was given. And then we can say angle B is 110, also because of co-interior. And then AE is parallel to BC. So therefore, we have angle A equal to angle C1 and angle B equal to angle E1. And therefore, we can say AB CE is a parallelogram, both pairs of opposite, and we can only give a reason from this list here. And that list is number 3, both pairs of opposite angles equal. Oopsie. Let me just move the screen a little bit. equal. Okay. We didn't solve for C2. That's okay, Tuli. We didn't really need C2 for our proof of the parallelogram. We could solve for C2 by doing angle sum of a triangle. Okay, right. Give a thumbs up in the chat if you are feeling comfortable with what we just did. And you can give a thumbs down, but then you have to ask a question. So thumbs up or question. Okay, so the next question, great guys, glad to see that you are feeling good about this. The next one is probably the last one. These questions take a lot of time, but it's probably going to be the last one we have time for today. So I want you to give this a go on your own first. So you're going to go through that same process. You can quickly redraw it wherever you are working. And then Hopolang, you must ask questions, sweetie. Hopolang, Patricia, you must ask questions if you are not understanding. Put it in the chat or raise your hand or pop it over to Miss Kat. Miss Kat, will you reach out, please? Okay, everyone else, I'm going to give you about 3 minutes here to work on this question by yourself first. Use your colors, fill in your information first, and then start working on solving the question. Georgia Lynn, you as well, you gave a thumbs down, you must ask a question, or Miss Kat will also reach out to you. Let's see where we can help you gain understanding. Okay, we'll see if you have time, but I also would like you to ask something specific, like where did we lose you? Which part didn't make sense? Because it was quite a long question, so it will just help if you could say where it was that you didn't feel comfortable, which part you got confused with. In the meantime, give this one a go. Start by filling in your information. Because the sketch is just blank, but there's lots of stuff written. And your brain can't think in two places. It's hard. So put the information onto your diagram. Redraw it quickly and then just put everything that's written onto the diagram. And then you start looking for angles using your other geometry, angles and sides. Okay, right, everyone, because we are a little bit pressed for time, we are going to get going. So as before, I'm going to use my orange to write down the things that are given. So what's given is that E1 is 62 and P1 is 68 and P2 is 56 and FP, this one here, is equal to Fn, All right, see where this is going again. We've got another little isosceles triangle here. And LE is equal to LM. Oh, and another one over here. Okay, so now I'm going to take another color and work my way through and find some angles and things. I go on my fact-finding mission. Okay, so I'm going to start. If you don't know where to start, always start with what is given and try and find another angle or side that is equal to the angle or side that is given. So I'm going to start here with the 56, and I'm going to say this angle is 56 because of angles opposite equal sides. And then I'm going to go to my other isosceles triangle, and I'm going to say that this is 62. Angle M1 is 62 because of angles opposite equal sides, but in that triangle. Okay, so not much else to do besides maybe finding F2. F2 we can find using the interior angles of a triangle. So 180 minus 56 minus 56 is 68. Okay, and if that is 68, then I can do angles on a straight line again to find 112. Okay, and I can maybe also find this angle using 180 minus 62 minus 62, and that is 56. Yeah. Yes, Layla. Question. Layla, you have a question? You can unmute. Layla, we're waiting. Okay, then I'm going to go to Mandisa. Mandisa, what's your question? Mandisa, you can ask your question. Okay, then I'm going to go to Asanda. Asanda, you can ask your question.
Hi, Efro.
Hello.
I wanted to ask, what is the difference actually between co-interior and interior angles?
Okay, so co-interior has to do with parallel lines. They go with parallel lines. Yeah. And interior angles, like if you look at triangle LEM, the interior angles are 56, 62, and 62. Do you notice that?
Yes, I noticed, Efro.
Yeah, so it's inside the shape. I think Miss Kat did write something there. Yeah, interior angles are within a shape.
Thank you.
And Layla, are you there now?
Ma'am,
Yes.
I wanted to ask if E2 would be 118.
E2 will not be 180, but it will be 180 minus 62, because together E1 and E2 gives you 180. Okay, so it will be 118. Or did I hear you right? Did she say 118 or 180?
I said 118.
Okay, yes, then you were right. Well done.
Thank you, ma'am.
Okay. Okay, so let's go to answering our questions. Okay, so we've got 2 more questions. Bom, you go.
Hello, ma'am.
Hi there.
Ma'am, I wanted to ask if can P1 equal to M2 because of co-interior angles on a triangle in a triangle.
P1 equal to
M2.
M2. No, that won't work. Because we don't have parallel lines yet, and they're not related in any way. P1 and M2 are within that quadrilateral LPFM, but No, they won't be for those reasons. So P1 is 68 because it was given. Okay.
Okay, ma'am.
Okay. Okay, here's Hopolang. Let's hear Hopolang.
Oh, hi, ma'am.
Hi there. I can hardly hear you.
Shouldn't E2 be equal to 112 because of co-interior angles when you subtract 180 with 68?
Okay. You are assuming that LM is parallel to PF, but remember we can't assume. So we don't know that those two lines are parallel. So we can't use co-interior angles. Okay. So be careful not to assume things.
Thank you, ma'am.
Okay. And last one from Tandiwa. Tandiwa. Oh, Tandiwa says, never mind, I got answers. Okay. Okay. Okay, Sipukasi, last question.
Hi, ma'am.
Hi.
Ma'am, I wanted to ask if M2 can be equal to F2 as corresponding angles.
Only if those lines were parallel, but we don't know that.
Oh, okay. Thank you, ma'am.
Okay. Okay, so let's quickly write our proof just before we run out of time. Angle N is equal to P2, and the reason for that is angles opposite equal sides. And then we got F2 is equal to 68, and that's because of angle sum in a triangle. That's what we use to find it. And then we actually see, but P1 is equal to F2. And they are actually in the alternate position. Sipagasi, I thought you asked your question. Did you not ask a question? Sipagasi, you can unmute and ask. Oh, yeah. Thanks, Verona. But I think Sipagasi is good. So P1 is equal to F2. You see how you guys see how we got there using other geometry. And now we notice, oh, but P1 and F2, those are actually alternate angles. So now we can say, oh, because these alternate angles are equal, LP is parallel to MN. Alternate angles equal. But never before we actually got there did we say that lines were parallel or anything like that. We can only do that once we've proven it. Yes, Andy, if opposite angles are equal, then it is a parallelogram. Okay, so that's going to bring us up to number 2. So for number 2, we're going to say that, what do we need to do next? M1 is equal to 62. And the reason there is angles opposite equal sides. And we'll get that L is 56 because of angle sum in a triangle. Okay, so that gives me L equal to N. So that's one pair checked. Okay. Now, how will we find M2? M2 we'll get by using co-interior angles. No, sorry, by using alternate angles. M2 will now be equal to 62 because we've proven, and I'm going to put what we've proven in a different color. We've proven that LP is equal to MA. If we don't know it, if we didn't prove it, we can't say that it is so. Okay, and that's a bit true in life as well, especially when we are dealing with other people. We can't just say things about other people without the facts. So geometry is a bit like that. So M2 is equal to 62 alternate angles. LP parallel to MN. And that means M1 plus M2, what does that give me? 62 plus 62, that's 124. And P1 plus P2 is 68 plus 56. That also gives me 124. So that's my second pair of angles that are equal. So angle L equals angle N and angle M equals angle P. L equals N and M equals P. And therefore LMNP is a poem. For that same reason, both pairs of opposite angles equal. Okay, right. That's it, guys.